So circle the type of function and justify your thinking. So what was the first difference on this one? What was the first difference? Say it again. 5. Okay, so we're going up by 5 each time. And it has to work for every single one, right? Now, if the first difference is the same, what type of function is it? It's linear. Okay, so we're going to be right here. It's going to be linear because the first difference is the same. Okay, questions on that one? Okay. On the next one, the first difference, this goes down by 6, this goes down by 4, this goes down by 2, this goes down by 0. So the first difference is not the same. It's definitely not linear. This has a difference of 2. That's going to be quadratic. So the second difference is the same. It's going to be quadratic. Questions on that? Okay. On the next one. First difference is 2. Next one's 4. 8. 16. Now, the second difference is not the same, but it's got the same pattern going on from the first to the second difference. We see that? And we see that it's being multiplied by 2. Okay. So that's still going to be exponential. Still going to be exponential. Okay. Questions on that one? All right. Go ahead and take a look at 18. What this is asking you to do is look at when x is 2, what's your y value? So for h, I know this one's a little harder to see. I'll zoom in so that y'all can actually see it on my page. Yeah. It's like, for instance, h of 2. I'm going to look at the graph for h. I'm going to say when x is 2, what's our y value? So right here, this is going to give me a y value of 4. So h of 2 is 4. Okay, so that's how you go about doing this one. Go ahead and take a moment and try those. Okay, so g of -4. So we're going to look at when x is -4, what is our g function? And that's going to be actually -4. F of 0. F is this function that's an exponential. So that's right here. That's 1. Everybody see where I'm getting this from? Okay. G of -8 is greater than f of 0. You're trying to say whether this is true or not. So g of -8. So if we go to -8, that's 0. And then f of 0. So that's 1. Okay. Is this a true statement? Is 1 bigger than 0? No. Okay. This next part is very similar to what you're going to see on mastery check. Okay. So it says given f of x, here is the equation. And then here's a table. Determine the following. Which one has the greatest y-intercept? So for instance, how do we find the y-intercept from a table? How do we find the y-intercept from a table? Look at where x is 0. Okay, so when x is 0, what's our y? And what is that? Look at our table. What is it? 0. How do I do it from an equation? You look at the b value. You could, I don't know if I would look at the b value. What you could do, and this works for every single one, is you could plug in 0 in for x. So type this into your calculator. So 5 times 1.5 raised to the 0 power. And that should give you 5, right? So which one has the greatest y-intercept, the equation or the table? Equation. So we're going to say f of x has the greatest y-intercept. Okay. On the next one, it says which function has the greatest y value when x equals -1. So we're going to look at when x is -1 in the table, what's our y value? 4. And then when x is -1, we're going to plug that into our equation. So type this into your calculator. And tell me what you get. So you're typing that into your calculator and telling me what you get. Let's put it right there. Thank you. So what'd you get? You're typing 5 times 1.5 raised to the negative first. 3.3. Is 4 or 3.3 bigger? 4 is. So that's g of x. Can you answer part C? All right. So what I got was 4 is less than 7.5. Is that a true statement? Yes. Okay. The reason why I got that is from the table, when x was 1, y was 4. And then we could plug in 1 into the equation. Questions on that?
Wouldn't it be the other way around?
Oh, you're right. Pause. So f of 1 would be 7.5 less than 4. Is that a true statement? JK. No. This is why you should always pay attention to what you're doing. I think you're catching that. Okay. All right. Now this one, this is what's going to be on your mastery check. There are 3 questions on your mastery check, and here are what they are. There's going to be a question about in behavior, which we're about to go back over in just a second. There's going to be a question about average rate of change, which is what we're doing in just a second. And then the last one is which one has the highest initial value, which is a fancy way of saying y-intercept. Okay, we already went over the y-intercept one. Now we're going over the average rate of change one. So just a reminder, average rate of change is y2 minus y1 over x2 minus x1. Whatever interval they tell you, that's your x1 and x2. And now to figure out your y1 and y2, you've got to use either the table or the equation that they gave you. So look at when x is 0 and x is 1 from the table. From the table, when x was 0 and x was 1, we have x1, x2, y1, y2. Now we're going to take all of that and plug it into our equation. So that's going to give me 4 minus 0 over 1 minus 0. So that's going to give me an average rate of 4. For the equation, if I take 0 and I plug it in for this x, that's going to give me 5. If I plug in 1 into this equation, that's going to give me 7.5. So this is our x1, y1. This is our x2, y2. And I'm going to plug those in. So this will give me 2.5 over 1, which is 2.5. So which one has a bigger average rate of change? G of x. We're going to read over these descriptions, and we're trying to decide whether they are exponential, linear, or quadratic, just based off of what they're describing. Now, just a refresher, linear is going to be when you add something Okay, quadratic is going to be when you square something. Exponential is when you're going to multiply something. So like if you double, triple, etc. Okay. On here, it says a sample of carbon starts with 128 grams and half of its decays every 5,730 years. So do we have linear, quadratic, or exponential? Is this adding or subtracting? No. Is it squaring something? No. It uses the word half, which means that we're multiplying by 0.5. So this is going to be exponential. Now, Marcia opens a bank account and deposits $3,500 into it each month without any withdrawals. So is that adding, squaring, or multiplying? Adding, so that's going to be linear. This next one is trying to trip you up. Don't let it. Susan owns a bakery and charges $2.19 per pastry she sells. Is that adding, squaring, or multiplying? Adding, okay? So each time she does $2.19, multiplies it by how many pastries she's got, and that's adding to it. Okay. This next one gives us a table. So I would find the first difference. And then find the second difference because they're not the same. The second difference is the same. So which one is it? Linear, quadratic, or exponential? Quadratic. Everybody see where I did that?
Isn't that like plus 111? Like the third.
You might be right. So this is 11, and then this is 121. Yeah.
Like there's like 100 and 110.
Okay, so the difference between this to this is 100, right? This one is 110. And then this one is 111, right? Okay, and then the difference between these would be 10 and then 1. 121. There we go. All right, try this again. Today has not been my day. I'm just going to clarify that. All right, 100. And then right here, it's 110. Everybody good? And then this one is 121. Okay, the difference between this is 10. The difference between this is 11, right? Well, can we make that assumption? So let's look at it this way. What if we took 1,100 and divided it by 1,000? What does that give me? It's like 1.1. What if we took 1,210 and divided it by 1,100? That gives us 1.1. So it's exponential. There we go. Exponential, because it has the same rate that we're multiplying by each time. So remember, if the first difference isn't the same and the second difference isn't the same, it's probably going to be exponential, but we've got to make sure that it's going up by a rate. Yeah. Take a moment, try those next 4. Try the boxes down at the bottom. So nobody say anything otherwise. I'm assuming you got the same thing. Quadratic, exponential, linear, quadratic. Yeah. Okay. Go ahead and flip to the next page. I'm going to kind of help me reason through some of this. All right. So for Rita's birthday, her grandma's given her 3 different options. This is option 1. I'll give you $2 a day for X numbers of days. Okay. Option 2. I'll give you the amount of money that is squared the number of days that you wait to ask me. Number 3, I'll give you $2 now and double your money every day for the next X number of days. okay? And we're gonna complete the table with that information. So looking at the first option, I'm gonna give you $2 a day for X number of days. What kind of function is that? Linear, quadratic, or exponential? Linear. Okay, so when we write a linear equation, remember, we're gonna use y equals mx plus b. So we're doing $2 a day. That's 2x. And how much did she initially start with? 0. So we're going to have 2x as our equation. Okay. On the next one, she says that she's going to square the number of days that you wait to ask. So squaring is what kind of function? Quadratic. So that's going to be x squared. Now, on the last one, it says, I'll give you $2 now and then double your money every day for the next X number of days. So we know that this is going to be exponential. We're doubling, so we're going to say 2 to the X. But we're going to say plus 1. And the reason why we're going to say plus 1 is because at the first day, Grandma's going to give us $2. Okay? Or on the zero day. I don't know how to say that. 0 day, I'm going to get $2. Okay? Now, what I'd like for you to do is you're going to take your X values and you're going to substitute them into this equation. So for instance, if I plug in -3 into this equation, I'm going to get -6. If I plug in -3 here, I'm going to get 9. And if I plug in -3 here, I'm going to get like 1 point something. Okay. What I'd like for you to do is take a moment and fill in this table. Okay. So substitute those numbers in. I'm going to give you 2 minutes. So you should have gotten these for the positive numbers. Are there any questions about anything? Are we okay with substituting them in? Okay. Go ahead and flip over to the back. And on the back, you're going to draw and label each of the graph on the same set of axes. So if you put these all into Desmos, this is what you're going to get. There's the quadratic, here's the linear, and then here's the exponential. Okay, so go ahead and take a moment and go ahead and graph all 3 of those on the same plane. Pay attention, now's the time. Domain and range. Domain is going to be all real numbers for all of them. Every single one. Okay, so domain is going to be all real numbers for all 3. Range is where it's going to get a little different. Range for linear is going to be from -infinity to positive infinity, so all real numbers. Okay. Your quadratic is going to be from 0 to positive infinity for your range. It doesn't go below 0. And then for your exponential, it's going to be from 1 to positive infinity. Okay. The reason why it's 1 to positive infinity is because our asymptote is at 1. Okay. Description of the shape. For linear, you're always going to have a line. Quadratic is going to be that U shape. And then exponential is just like a curve. Characteristics that make each function unique. Quadratic is always going to have a max or a min. Exponential is always going to have an asymptote. Now, does it really make sense to have negative numbers in this situation? It makes sense to have X number of days be negative? No, because days are not negative. You need to be able to compare all these different functions to each other for various key features. So on this first one, it says, I have the smallest y-intercept. From a graph, how do you find the y-intercept? Okay, so where it crosses that y-axis, right? Okay, so looking at our first 2, where do they cross the y-axis? Well, this one crosses at 0, 1, and this one crosses at 0, -2. Okay. From a table, how do we figure out what the y-intercept is? When x is 0. Well, does it say it in our table? No. Okay, so we've got to find it. We know that 0 would be right here, right? So what's the pattern that's going on? Well, this is going up by 2. And we know that 0 is halfway between these two numbers, right? So what's halfway between -5 and -3? -4. So this is going to have a y-intercept that's -4. From an equation, how do we find the y-intercept? Plug 0 into the equation. When I plug 0 into that equation, I'm going to get -7. Which one is the smallest y-intercept? B of x. All right. Which one represents linear decay? So which one is a linear function and is going down? Look at it again. A of x, right? Okay. Which one is going to have an asymptote? So which one is exponential? That's what that's asking. B of x and d of x. D of x is also exponential because it has an x in the exponent. Constant rate of change is talking specifically about linear functions. So we know that a of x is a linear function, but also c of x, because this has the same first difference. All right, x-intercept. So right here, it crosses at 2. Here it crosses at about -1. How do we figure it out from a graph or a table? How do we figure out x-intercepts from a table? Where y is 0. So where does that happen? Well, that happens like right about here. Okay. So we know that these numbers are going up by 2 as well. So this would go up to 5. Oh, JK. This would go up to 4. So it'd be 4, 0. And then the last one, you could set this guy equal to 0 and then solve. So we would add 8 to the other side. And you would ask yourself, 3 to what power would give you 8? Well, 3 to the first gives us 3. 3 to the second gives us 9. So that means that it's somewhere in between 1 and 2, right? So which one has the largest x-intercept? C of x. Okay, in behavior is on your mastery check. So really quick, as we move to the right, so as x approaches positive infinity, this guy's going to positive infinity. So which one is constantly increasing? C of x. Can you take a moment and try the next 3? Okay, so for always decreasing, I got a of x. For restriction to the range, that's going to be b and d, because those are both exponentials. And then for domain, that's every single one of them. Okay. Are there any questions on that one? Okay, this is all very similar to what you're going to see on that mastery check. So go ahead and flip over to the other side. I'm going to give you a couple minutes to work on those. Okay, try to get as many as you can done. Now, all of them are on a graph. On your mastery check, you're going to have one table, one equation, and then one graph. So go ahead and take a moment. Go ahead and work on those. Okay, on this one, always decreasing, it should also have b of x on there, because this one's going down the entire time. Yeah. Yep, that's it. All right. Okay, so help me out. What is the largest y-intercept? A of x. Okay. What about exponential growth? And what about asymptote? BD. Constant rate? B and C. Largest x-intercept? B and C. In behavior, that as x approaches positive infinity, I approach negative infinity. So as we move to the right, it's going down. That's this guy, which is A. I can't see it. Yeah. Always increasing, that's going to be D, C. Restriction to range. Remember, that's going to be your asymptotes or your exponentials. So B and D. And then this last one probably trips you up just a little bit. So this is x is greater than -8. So looking at when x is -8, are all of my functions on this side? Like, does it all stay over here? Like, you didn't plug in -9 into the equation. No, you plug in -9 into all of these equations. So none of these have a domain of just x is greater than -8. Because remember, our domain is all real numbers. So I can plug in any x value into all of those functions. Okay. On your mastery check, these are the 3 questions that you're going to be asked. It's going to ask you about y-intercept or your highest initial value and compare them. Okay. It's going to ask you for the average rate of change. Okay. And then the last one is going to ask you about in behavior. I do want to kind of make a comment on this. Looking at this in behavior, if I wrote this out in notation, this would say as x is approaching positive infinity, y is approaching negative infinity. Is everybody okay with that notation? This is saying as we go to the right, we're going down. If I had as x is approaching negative infinity, y is approaching positive infinity, that means as we move to the left, it's going positive. Okay. All right, so what I would like for you